Hi everyone, this video is the solution to example 1 on the topic of complex stress. In this particular exercise, we have the stress state in 2D of a given point, and what we need to do is calculate the principal stresses and also the angle of rotation to get those principal stresses and the maximum shear stress. Before we start doing this, we need to discuss the sign convention. And in this problem, the sign convention we're going to use is assume sigma x and sigma y to be positive when they're in tension. So sigma x will be these two forces and sigma y in the y direction. And then we're going to assume the shear force tau xy to be positive when it's acting in this direction. So tau xy will be here in green, and sigma x and sigma y will be in red. This particular problem, by looking at the sign convention, we can state that sigma x is going to be equal to 80 Newton per millimeter square. Sigma y is going to be 35 since it's in tension, and then tau xy, based on the convention, will be minus 30 since the positive direction is the opposite as the one is drawn here in this problem. So with this in mind, the only thing we need to do is use the formulas to calculate the principal stress. So this is the formula for principal stresses. So sigma 1 and sigma 2 are equal to sigma x plus sigma y over 2 plus minus 1 over 2 and then a big square root. And now inside brackets sigma x minus sigma y squared plus 4 times tau xy also squared. So if we know this is the formula we need to use, we can replace it straight away and get our final result. So in this case, this will be 80 plus 35 divided by 2 plus minus 1/2 square root of 80 minus 35 squared plus 4 minus 30 squared. If we take the calculator, this is equal to 57.5 plus minus 37.5. So that means sigma 1 is going to be equal to, with a plus sign, 95 Newton per millimeter square, and sigma 2 is going to be equal to 20 Newton per millimeter square. Both of them in tension, and this is it to solve for the principal stresses. Now, another thing that it's asked in the question is the principal planes. So the angle theta we need to rotate to obtain this principal stresses. To do this, we use this formula. So the tangent of 2 theta equals to 2 times tau xy divided by sigma x minus sigma y. Again, if we apply this to our specific set of numbers, so this is 2 times minus 30 divided by 80 minus 35. So if we put this in a calculator, we get minus 1.333, which means if we do the inverse tangent of this, we get that 2 theta is going to be equal to the inverse tangent of minus 1.333. So 2 theta is equal to 307 degrees, which means theta is going to be this divided by 2, which is equal to 153.5 degrees. So based on these conventions, if theta is positive, that means it's a clockwise rotation. So that means if we take our initial square and we rotate it 153 degrees, so if we take it at its original position and we rotate it 153 degrees, something that looks like this, our square will be aligned somewhat like that. So I'm saying that this face here of the square will be this face here. And when we do this rotation, we will have sigma 1, so of 95 acting in this plane, and then 90 degrees after 20 acting in the other plane. So this is it. And finally, the last question is the maximum shear stress. So the formula for tau max, for the maximum shear stress, is equal to sigma 1 minus sigma 2 divided by 2. So we calculated this already, so it's 95 minus 20 divided by 2, and this is equal to 37.5 Newton per millimeter square. And this is it. Thank you for watching this video. So far, we're just applying some formulas, and we're going to continue with this topic in the next videos. Thank you for watching.